Hello and welcome to Built and Deployed, the video series where we look at systems architectures built on OCI. I'm John Troyer. I'm with Oracle Cloud Infrastructure. So I'm really pleased today to have with us a special guest, Amit Kumar from BIAS. So today we're going to talk about a project that you did recently with a customer. Can you tell us a little bit about the customer and the project they were facing?
Absolutely, John. Hi, everyone. This is about, a global customer recently whom we migrated from their on-premise architecture to Oracle Cloud Infrastructure. A customer, we're going through a lot of challenges in their on-prem environment with respect to reliability of the environment, availability issues. They were hitting end of life with respect to, coming year, and they were pretty much at the verge of, deciding what makes sense, whether to invest handsome money in on-premise infrastructure, or whether to see something which is more lucrative with respect to the immediate capex and future flexibility. And that's where they started exploring about various cloud solutions.
Well, let's go straight to the diagram, because today we're talking about this particular system architecture. And in particular, we're talking about Oracle E-Business Suite, EBS. So they had EBS on-prem, they had some data centers regionally, and this is the architecture that you and your team came up with and helped them build and deploy. Can you walk us through some of the features around resiliency and redundancy?
Absolutely. So, when we started exploring, the possible architecture for this particular global customer, what we came to know that they had two data center at their primary location, pretty close to each other, like almost like you can say within 50 miles of range. So and both were connected through a point-to-point 1 gigabyte bandwidth. Now that's where we came up with an idea where we planned two redundant fast connect, from Oracle Ashburn data center as a primary location. And what we did that one fast connect going from Ashburn all the way up to their first data center, and the second fast connect going to their second data center, where they were already connected with each other, through their point-to-point connection. Along with that, we also designed, a backup failback IPsec network for for both of their, data center location. So that was at high level their primary architecture, primary data center architecture. With respect to their disaster recovery network architecture, we designed, two failback IPsec, VPN connection there. So that's what, their whole network architecture looked at very high level. So if you will see, if one fast connect goes down with respect to their other data center, we ensured that the second fast connect connected with their second data center automatically takes over the whole production load. And in case both fast connect fails, then automatically IPsec VPN will take over, the role to ensure that users do not feel any network, connectivity. So almost like a triple layer of redundancy, which we build as part of their network architecture.
Well, so with that much redundancy, surely that would never happen in real life. Did anything like that ever happen with the customer?
That's pretty interesting, okay? Because when we designed, it was just like, okay, because we had that option, we wanted to maximize the benefit with respect to Oracle Cloud and the architecture what they had. It was pretty interesting that, with the connectivity what client had from their cloud exchange partner all the way up till their data center, that was a single point of failure, okay? Recently, couple of months back, almost, I would say 6 months after their OCI go live, their cloud exchange partner reported them a cable cut, underground cable cut situation, where their fast connect network, went down because the connectivity to their data center was no more available at that point of time. That's where, immediately the IPsec VPN, which we set as a backup failback network, it took over that connection. And while that network connectivity got restored, which took like close to 8 hours for their cloud exchange, third party partner, production users, they did not even experience that there was a network down situation, which infrastructure team was encountering. So it was pretty pleasing experience for them, although we just build it as a layer, because IPsec is pretty cheap option, and we felt like, okay, there was not much investment which you have to go and do towards it, but it became a lifesaver for them when they hit the real time issue with respect to those kind of unplanned situations.
Right, protected against both squirrels and backhoes, probably.
Absolutely.
I wanted to talk a little bit about the application architecture itself. So you had redundant application servers in there with Oracle E-Business Suite. And then each one of those was in a different fault domain. And then also you had you were using a database cloud service. So there, for the databases for these applications, and each one of those was also in different fault domains. Is that kind of a standard practice, or how are you thinking about that?
What we generally recommend is like, obviously high availability architecture, and try to find a middle ground with respect to the overall investment which client wants to do, and maximize the benefit of that. With respect to that particular requirement, client in their on-premise, they were running a single tier architecture, both for their one internal tier and one DMZ tier. When we implemented, their architecture in OCI, that's where we added, a second internal node for them, as well as a second DMZ tier. And when we did that as part of, the availability domain in which we implemented their architecture, we ensured that the second server, the second VM, which we deploy within the same availability domain, we provisioned it, in the second fault domain, so that in case one fault domain goes down, that, you have a redundant set of, infrastructure in the Oracle data center, which will ensure that your environment is available and fully functional. So that's what we did, both as part of, a database as well as the application tier architecture.
Nice, nice. And then you also had a second OCI region set up as a disaster recovery, a DR site. Can you talk a little bit about that, how that was configured, and maybe some of the capacity analysis or capacity sizing that you had to do there?
So for this particular client, earlier what they have in on-premise was mainly a database DR failback plan. They never implemented any application, a disaster recovery architecture. Neither they ever tested it. So the idea was that if they fail, only they would be able to restore the data. They'll wait for the primary site to come up, and then they'll ensure that their data is protected. But fully functional application, it was like one of their expectation from the management, which the infrastructure team was struggling to meet with.
But a disaster recovery plan of only the database that has never been tested is not really a very functional disaster recovery plan as a best practice.
That's very true. It was only providing them a data safety, nothing beyond that, because in those situations, your RTO becomes pretty dominant in terms of how many days it will take to fall back or become operational, depending upon the kind of disaster you hit in your primary data center.
Mm-hmm. So you built a whole new stack then in the new region.
Exactly. So as part of this, what we did, when we deployed their application, VMs and services in Ashburn as a primary data center, in Phoenix, we planned a skeleton DR architecture. When I say skeleton DR architecture, it's like 364 days in a year out of 365 days, you will run your DR with a minimal amount of cost, where you go and provision your DR VMs only to sync the data with the limited amount of CPU, what is really needed to keep you in sync at DR location. When you do that, you keep the price down. when you get into a real DR situation, or you plan a real DR exercise, let's say, an annual DR exercise, which we always, strongly recommend. At that time, we scale the CPU, of the VM which we deployed on the other data center. And when we do the failover and bring up the services, it gives the capability to client to really, match the resources what they have on their primary side in order to do a fully functional DR test, not just in terms of functionality, but also in terms of performance and load testing. That's what we did as part of this exercise. That, we scaled up their CPUs both on database and application tier, did the failover exercise, brought up services, pretty much within the expected RTO RPO window, and went with that's where clients spend the time, with the detailed testing. Once the testing cycle got completed, we scaled it down, and they were back to what they were supposed to spend, the minimal amount to maintain the DR in sync disaster recovery data center. So this whole thing, when we did for them, pretty much within 2 weeks, starting from building and failover, the whole testing cycle. So it was a pretty pleasant experience to them, where user did not even realize that we have switched a data center from Virginia to all the way to Phoenix, and everything has worked so great for them.
Amit Kumar from BIAS, talking about an actual customer in OCI who has built and deployed this architecture. I'm super impressed. Thank you so much for coming on Built and Deployed.
Thank you, John. It was great talking to you guys.
And thanks everybody for joining us. Join us next time for another episode of Built and Deployed, where we talk to OCI customers about actual system architectures that they have designed, built, and deployed.